Hello everyone, welcome to A1 Tutor Live class and welcome to physics class. Once again, we welcome you to our online class. Last week, we treated a topic that has to do with tension, that is the strain and the stress. The strain and the stress, and also we discussed the Young modulus, which led us to take some calculation on that topic. We're able to have some calculation under Young modulus. And today we are having the third part of the topic elasticity, which is elasticity part 3. And we'll be considering the last subtopic under the topic elasticity. Today we'll be looking at what we call work done in a spring. Work done in a spring, or what we call the potential energy in a spring. Work done in a spring, or the potential energy in a spring. So to start with, we are going to define what is work done in a spring. When we explain the terminologies of elasticity, we made use of a spring. We said a spring is a good example of an elastic material because it can be compressed, it can be stretched. A spring is a good example of elasticity. Like what we said in the first part of the video, a spring has the ability to be compressed and it has the ability to be stretched. So in this topic, we are focusing on a spring as a good example of an elastic material. So we want to look at work done in a spring, and that will majorly be calculation. We're looking at how to calculate work done in a spring. First, we have to define what work done in a spring is. We are going to take the definition of work done in a spring. That will be the first thing we'll be taking. Work done in springs and elastic strings and elastic strings. So we are looking at two things: work done in the spring and work done in an elastic strings. Work done in an elastic string. Now let's look at the definition of work done when it comes to elasticity. What is work done? Let's consider the definition of work done. Work done, we define work done is defined as follows. Work done in stretching, work done in stretching a spring or an elastic string is the product. Of course, you should know that product has to do with multiplication. Product is multiplication. So is the product of average force stretching the spring or the elastic strings. So it is the product of what? Average force. So average force has to be with the initial force, initial plus final divided by 2. That is the initial force plus the final force applied divided by 2. You're going to get the average force. So let's have this as average F, which represents force. That will be equals to the initial is taken to be 0. The initial force is taken to be 0 Newton, while the final force is going to be a particular value. So let's use F to represent it as final. F to represent final. So we have over 2. This is equals to F, F over 2. That's the average force, F over 2, or we write it as 1 over 2 F. 1 over 2 F. Now that is the interpretation of the average force. You know, I said earlier or in the previous classes that for us to stretch a material or to actually compress a material, we need to apply force. Let's say this is an elastic material. If I'm going to stretch this, I will need to apply force. If I'm going to compress this, I'll need to apply force. And that is why we are taking the average of the initial force and the average of the initial force plus the final force. Adding them together, then divided by 2, you're going to get the average force in that work done. So it is multiplied, the average force is multiplied by the extension produced. By the extension produced. If you are compressing an elastic material, of course, the length will change from the initial length to the final length. And if you are stretching an elastic material also, the length will change. There will be a change in the length. And that change is what we call the extension. It's either the extension in stretching or the extension in compressing that particular elastic material. So we are to take the product of the average force and the extension. So let's say extension is represented by extension is represented by letter E or X, depending on some textbooks. Some textbooks will use X, while some textbooks will use E. All right, so X or E represents the extension produced after applying force to the elastic material to stretch or to compress. So if we said it is the product, if work done is the product, that means W is equals to the product of the average. The average was calculated to be this. That is 1 over 2 F multiply, which is product, multiplied by E. If I'm going to use E, I can use E. If I want to use X, I can use X. So this is going to be equals to 1 over 2 F E. 1 over 2 Fe. So we have this to be the formula for work done. The formula for work done is what? Is given as 1 over 2 Fe. 1 over 2 Fe. Also, we can simplify this to be another formula by saying recall that F, which is force, is equals to Ke is equals to Ke, where K is the elastic constant, where K is the elastic constant, K is the elastic constant, and E is the extension. So if I replace F now by this formula, I'm going to have 1 over 2 Ke into bracket E. And when you simplify this, your final formula is going to be work done is equals to 1 over 2 Ke squared. 1 over 2 Ke squared. 1 over 2 Ke squared. That will be the formula for work done. So we have been able to derive the formula for work done using the definition. So it's either I use this formula, I have two formula now, that work done, which is W, is equals to 1 over 2 Fe, that is if force is given, or I use it as 1 over 2 Ke squared. 1 over 2 Ke squared. So this is the formula we're going to be using to calculate the work done in this particular topic. I believe that is clear to us. The derivations of the formula for work done under elasticity. If that is clear, please let's signify as we are going to commence solving questions under this subtopic. If it is clear to us, let's signify by using a thumbs up, by giving a thumbs up, signify so we can proceed to solving the questions. All right. Thanks for your response. Blessings. So now let's proceed. Let's proceed to solving question that has to do with work done under elasticity, especially in springs and elastic strings. We are going to take the first question. So we have question one. Question one. Let's bring our question and we can start solving. So question one. So we are given question one. The energy stored, take note, when you have the word energy stored, it's also synonymous to work done. Because work done in an elastic material is the energy stored in that elastic material. Okay, work done in an elastic material is the energy stored in that elastic material while it was stretched or compressed. So the energy stored is also synonymous to the work done. So we are asked to find the energy stored in a spring of thickness constant K, that is K was given to be 200 Newton per meter. That's the elastic constant. When extended by 4 centimeter, that is extension, which is E, and also can be taken as S, is given as 4 centimeter. And we are asked to find the energy stored. We are asked to find the energy stored. So what we are asked to find is to find the work done, which is also W equals to 1 over 2 KE squared. This is also the same as saying energy stored, which is letter E, is equals to 1 over 2 KE squared. Because I told you earlier that work done is equivalent to the energy stored in an elastic material. Work done is equivalent to the energy stored in an elastic material. So I'm going to be using E, letter E, to represent the energy stored in an elastic material. Now, before we proceed to solve, take notes from the first topic that we treated in this live class. In case you are not chance to join us then, we still have it on YouTube. You can do well to search on our YouTube page for fundamental quantities and units. That's the topic. We discuss how we make use of our quantities in physics, how the units are being used also in physics. So we said then that length is measured in meter. In physics, length is measured in meter. So extension here is talking about length. So if I'm given the extension to be in centimeter, there will be a need to convert to meter. There will be a need to convert the centimeter to meter. And I'm going to do that is by dividing centimeter by 100. So 4 centimeter over 100 will be equals to 0.04 meter. So I'll be dividing 4 centimeter by 100. 4 centimeter by 100 because 100 centimeter makes 1 meter. 100 centimeter makes 1 meter. So I'll be dividing the centimeter given to me by 100. So I can proceed now to solve the question. Now that I have the length or the extension in meter, I can solve now. So E equals to 1 over 2 KE squared, which is equals to 1 over 2 multiplied by K was given to be 200 multiplied by E was given to be 0.04 all square. Let's write the square very well, all square. And this will be 2 year 1, 2 into 200, that is 100. We'll be having 100 multiplied by 0.04 bracket all square. 100 multiplied by, we need to simplify what is 0.04 all square, 0.04 all square. That is 0.04 times 0.04. We are going to have the value 0.0016. When you multiply 0.04 times 0.04, you are going to get 0.016. 0.016. So that will be the value. Now we can go ahead to multiply 100 with that value, multiply it by 100 to get the energy. The energy is 0.16. And because we are solving for energy, we are going to have the unit to be in joules. The unit to be in joules. So this is 0.16 joules, represented by letter J. So the energy stored in the spring, in the stiffness of that spring, is 0.16 joule. 0.16 joule. 0.16 joule is the energy stored in the stiffness of that elastic material. I believe this solution is clear to us. If yes, please do well to give a thumbs up. As we are moving on to the next question, we have many questions to solve. So if this is clear to us, give a thumbs up. We move on to question number 2. Give a thumbs up if this is clear to us. A thumbs up or drop a message that yes, it's clear in the chat box. And for our followers, our viewers on YouTube, watching this video, I want you to also give a comment on this question number 1. If the explanation was okay and self-explanatory and you understood it very well, do well to drop your comments in the comment section. And if perhaps you have a question to ask on this question, question number 1, do also well to drop your question in the comment section by tagging it. I have a question for this question number 1. Then you give your questions so we can get back to you on the question you're going to be asking us. Do well to feel free to ask questions as you are watching the video. Thank you. And also, please do not forget that when you subscribe to our YouTube channel, you have access to receive notifications concerning our videos anytime we upload videos on YouTube. Okay, now let's move on to the next question. That will be question number 2. Since I've received a positive response from people following us online that it is clear to them, let's go on to solve question number 2 now. So permit me to wipe the board. I hope you have taken this down, you have penned this down. Moving to question number 2. Question number 2. Question number 2. Question number 2. Let's have question number 2. Question number 2 is as follows. A spring of force. Now they gave us force. A spring of force, constant, 300 Newton per meter, is compressed such that its length shortens by 3 centimeters. Such that its length shortens by 3 centimeters. So that means when you compress an elastic material, there will be a reduction in the length of the elastic material, just a temporal reduction, because once you remove your hand, or probably you do not apply force anymore, it will go back to its original position. So the length it attains when it is being compressed is a temporal length, not the permanent length. It's just a temporal length. So the 3 centimeter is a temporal length when the spring was compressed, So let's go ahead to solve this question. We are given the first constant to be this, and we are given the extension to be 3 centimeter. We are asked to calculate the energy stored. So we have parameters in the questions. Parameters, we have K, which is also the force constant, to be equals to 300 Newton per meter, and also we are given the extension, which is letter E, extension to be 3 centimeter. Now you can see what I was saying the other time. We are given the extension to be 3 centimeter, which we cannot actually use like this. We need to convert the 3 centimeter. So I'm going to ask, what is 3 centimeter in meter? What is 3 centimeter in meter? What is 3 centimeter in meter? We've done the first one the other time by converting 4 centimeter to meter. Now I want you to do this for me. What is 3 centimeter in meter? I need your response in the chat box. What is 3 centimeter in meter? What is 3 centimeter in meter? Of course, you should know that 100 centimeter makes 1 meter. 100 centimeter makes 1 meter. So if you are going to get 3 centimeter in meter, you are going to be dividing 3 by 100, and that will be 0 0.03. 0.03. That will be the value. Now we can solve for the energy stored, which is 1/2 KE squared. 1/2 multiplied by K, which is 300, multiplied by the extension, that is letter E, which is 0.03 all squared. We have 1/2 is multiplied by 300. Of course, we can simplify this. We can simplify this expression. 2 divided by 2 is 1, and 150 divided by 1, or 300 divided by 2 is 150. So we have left with us, we have 150 multiplied by 0.03. 0.03 times 0.03 will give us what value? 0.03 times 0.03 should give us 0.0009. That will be the value. Multiplying that with 150, we're going to have 0.135 joule. The energy stored is 0.135 joule. 0.135 joule. So that will be the answer to this question. I believe this is clear to us. If yes, please, you can do well to give a reaction to show that it's clear to you. Okay, thank you, blessings. So now we are going to take question number 3. And this time around, I want your engagement because I'll be asking you to do some conversion for me. And I want you to give me response very fast so we can move on with the solution. So if I ask you to do some conversion or some calculation from your own end, I want your response to be swift. I want your response to be swift. So let's take question number 3. Ensure you have penned down this solution inside your notes. Question number 3 now. Question number 3. Question 3. Question number 3, we have this question to solve. Question number 3. We have the work done in extending a spring by 400 millimeter or 40 millimeter. The work done by extending a spring by 40 millimeter, that is extension is 40 millimeter, is this. The work done, W, which is also energy stored, is 1.52 joule. Calculate the elastic constant of the spring. Elastic constant is letter K. Elastic constant is letter K. So we are asked to calculate the value of K using these parameters, which is the extension and the energy stored. So we are asked to calculate the elastic constant, which is letter K. We have to record the formula for work done or energy stored, which is W equals to 1 over K E squared. 1 over K E squared. Now, what is our own concern? Our own concern is to get the value of K. So to do that easily, I would suggest that we make K subject of the formula. Make letter K subject of the formula. So we have make K subject of the formula. Make K subject of the formula. And the formula is given to be W equals to 1 over 2 K E squared. So we have to express K as the subject of the formula. So how do we do that? That is going to give us W. Use 1 to multiply K E squared. That is K E squared. Then everything will be over 2. If your W is expressed as over 1, by simple cross multiplication, you're going to have 2 times W equals to 1 times K E squared. And when you simplify this, 2 times W is 2W equals to K E squared. Now, how do you make K subject of the formula? You have to divide both sides by E squared. That is 2W over E squared is equals to K E squared over E squared. So if E squared cancel E squared, we have K to be equals to 2W over E squared. K equals to 2W over E squared. So to get the value of the elastic constant, which is letter K, I'm going to use this formula. K equals to 2W over E squared. K equals to 2W over E squared. So we need to substitute the value of work done and that of extension into the formula. But before that, we need to convert that extension value. It was given in millimeter, and take note that 1000 millimeter is equals to 1 meter. So if I'm going to convert this, it's going to be 40 divided by 1000, 40 divided by 1000, and that will give me the value in meter. That will give me the value in meter. So that will give us 0.04 meter. So we can go ahead to solve now. That K is equals to 2 times W is 1.52. 1.52 over E. Letter E is 0.04 brackets all square, because the E has a square. So this will give us, multiplying the numerator, that is 2 times 1.52, we are going to have 3.04 is divided by 0.0016. Dividing this to get the final answer, we are going to have 1,900 Newton per meter. The elastic constant K is measured in Newton per meter. So you have to add that to the final answer. The answer is Newton per meter. The unit should be Newton per meter. So we have it to be 1,900 Newton per meter. Newton per meter. That is the elastic constant, which is K. I hope this is clear to us. The solution is clear to us. I hope the solution is clear to us. If yes, let's signify. If you have any question, please do well to ask. You can drop your question in the chat box. You can drop your question in the chat box. And for those following us on YouTube, you can as well also drop the question in the comment section. Definitely, we are going to review them and give you your responses in due time. So if you have any question, please do well to drop your question so we can attend to it together. If you have any question concerning the topic work done in a spring or a strings, do well to drop your question in the comment section, and we are going to get back to you with your response. So if K is given to be this value, that means the elastic constant is 1,900 Newton per meter. Newton per meter. Now we are going to take the fourth question now. This is the third question we just solved. We are going to take the fourth question. I'm going to drop some question after these explanations as an evaluation questions. So let's take question number 4. Question number 4. Question number 4. So we go ahead to solve question number 4. Question number 4. We have this question. Question number 4. We have a force of 2.8 Newton is applied to an elastic string of length 1 meter. If the force causes the string to increase in length by 1/10 of the original length, 1/10 of the original length. Let's underline that. Calculate the potential energy stored in the string. Calculate the potential energy stored in the string. So for this question, we are not given the extension, but we are given what is going to get us the value for extension. First, we are given force to be 2.8 Newton per meter, and we are given the length to be 1 meter. Force was given to be 2.8 Newton, not Newton per meter, but Newton, and the length is 1 meter, while the extension is 1. The extension is 1. The extension is 1/10 of the original length So 1/10 means 1/10 of 1 meter. 1/10 of 1 meter. 1/10 of 1 meter. 1/10 of 1 meter. So if you are going to simplify that, your extension will be equals to 1/10 of means multiplication 1 meter. That is going to be 1 meter over 10. That is 0.1 meter. So the extension was calculated to be 0.1 meter. The extension was calculated to be 0.1 meter. Now with this, we are going to solve for the energy stored, which is E, energy stored. But before that, we need the value of K. The value of K, which is the force constant or elastic constant. Force constant or elastic constant. K was not given in the question. So to get the value of K, K will be equals to the force divided by the extension. The force divided by the extension. The force is 2.8 and the extension is 0.1, which will give us 28 Newton per meter. 28 Newton per meter. So we've gotten the value of K. Now we can solve for the energy stored. Energy stored, which is letter E, is equals to 1/2 Ke squared. 1/2 multiplied by K is 28 and E is 0.1 all squared. By simplification, we have 2 here 1, 2 here 14, and that's going to be 14 multiplied by 0.1 square is 0.01, and multiplying 14 by 0.01, the answer will be 0.14 joule. The energy stored in this particular elastic string is 0.14 joule. 0.14 joule. 0.14 joule. So that is the answer for this question. Okay, for the videos that we had yesterday, someone is asking the question how to get it. Of course, you are going to have it on YouTube. Just search for A1 tutor, okay, written like this, A1 tutor. Search for this on YouTube, A1 tutor. You are going to have the list of all the videos we have uploaded, and that of yesterday, you are going to see it there also. That of yesterday will be there. That will be the recent video you are going to be seeing under our page on YouTube. So just type A1 tutor on YouTube and you're going to have access to those videos. A1 tutor on YouTube. A1 tutor on YouTube. Then also I'm going to advise that you subscribe. Okay, once you subscribe to the YouTube channel, you don't need to be going through some stress to know whether some videos have been uploaded or not. You'll be getting notifications back to back. So just subscribe. Once you get to the YouTube channel, click on the subscribe button so you can be getting notifications of our videos. You can be getting notification of our videos on YouTube as time goes on. Okay, I believe I've answered your question. Thank you. Okay, thank you for subscribing to the YouTube page. We really appreciate. Also, you can do well to recommend this to your friends. Basi, you can do well to recommend this page to your friends also, so they can get videos of some topics they want to learn. All right. So that is for the fourth question. Now we are going to the fifth question, but we're going to take a pause and address our followers on YouTube that we always upload our live session class on the YouTube on daily basis. We have a way we upload them immediately after the classes, so they are always available on the YouTube page. So do well to subscribe, do well to share, like, and comment. Ensure you comment, you give a comment after you've watched the video. Drop your comments, drop your questions, drop any other questions that has to do with that particular topic inside the comment section, and we are going to give you your response. All right, we're going to give you a response. So thank you for subscribing, and thank you for liking our videos. So let's take question number 5 now under this topic. Question number 5. Question number 5 will be a bit different from the one we've been solving. So permit me to wipe the board. Question number 5. Question 5. Question 5. So for question 5, given that the energy stored in a spring, given that the energy stored in a spring is 0.25 joule, 0.25 joule, and the force constant that is K is given to be 200 Newton per meter. Full stop. Obtain the extension of the spring. Obtain the extension of the spring. That is the question. So we need to identify the parameters like we always do in physics. Identify the parameters given. That will make it easier to solve the question. So we are given the energy stored to be 0.25. So we have parameters. The energy stored is equals to 0.25 joule, and the force constant, which is this value, is 200 Newton per meter. The force constant is equals to 200 Newton per meter, and we are asked to obtain the extension, which is unknown value. So if E is equals to 0.2, which is energy stored, and K is equals to 200 Newton per meter, and E is equals to unknown, which is the extension. We're going to get that by making E, letter small e, small letters e, the subject of the formula. So I have E equals to 1 over 2 ke squared. So making letter E subject of the formula, that is the goal. Making letter E subject of the formula. We are still going to have on the next line 1 multiplied by ke squared. That is ke squared divided by 2. If E is expressed as over 1, by cross multiplication, we're having 2 times E is equals to 1 times ke squared. So by multiplication, we have 2E equals to ke squared. Dividing both sides by the coefficient of E squared, which is letter K, we are going to have 2E divided by K is equals to ke squared divided by K. K cancel out K. E squared is equals to 2E over K. But what we are looking for is letter E, not E squared. So I'm going to take the square root of both sides, the square root of both sides. That is square root of E squared and the square root of 2E over K. Square cancel the square root. So E now is equals to the square root of 2E over K. 2E over K. That is the square root. That is the formula for the extension. To get the extension, we're going to use this formula. So we've been able to make letter E, which is the extension, the subject of the formula. Now we can go ahead to substitute the stored energy inside what we've gotten and the constant force or the force constant inside the formula we've gotten. To do that, permit me to wipe the board. I need some space to do that. All right, let's just clean the portion of our board. Let's clean this portion so we can utilize this portion of the board. Let's print this portion. We're going to be solving it here. Getting the value of extension. So now let's go ahead to do that. Getting the value of the extension. If letter E, small letter E is equals to 2E over K all square root. It means that the square root of 2 times energy stored is 0.25 over the value of K is 200. That's 200. So we need to divide that first. First multiply 2 by 0.25. Write the answer, then divide it by the denominator. Divide it by the denominator. So if I multiply 2 times 0.25, that is 0.5 divided by 200. 0.5 divided by 200. 0.5 divided by 200. That is going to give us the value 1 over 400. 0.5 divided by 200. 1 over 4, which is also 0.0025. And we have to find the square root of this value. The square root of this value that will serve as the answer. And the square root of 0.0025 is 0.05. Now, is your answer going to be like this? Of course, the answer should have a unit because you are calculating for extension. And extension has to do with length. So if extension has to do with length, that means the unit of extension is what? Meter. The unit of extension is what? Meter. So the extension of this particular spring is 0.05 meter. 0.05 meter. 0.05 meter. I believe this is clear to us. I believe this is clear to us. If yes, please kindly signify. All right. Thank you for your response, Blessing. So we are going to take evaluation now. Evaluation. Evaluation period. Now, evaluation period, we're going to take 2 questions for that. We want to check our understanding based on what we've done on this calculation aspect. So we're going to take just 2 questions and we call it a day. 2 questions. Permit me to wipe the board as I will bring up the evaluation question. So we said we'll be having evaluation. Like I said, we'll be having 2 questions, and I want us to be very, very fast with it because it's almost the same thing we've been solving from question number 1 to question number 5. So I want our swift response. So let's take the first evaluation question. We are going to solve the question and drop the response in the chat box. And for those following online on YouTube, you can drop your question, your answer in the comment section. You can drop your answer in the comment section. You can drop your answer in the comment section. Okay, so this is the question we'll be solving. Evaluation question. Question. We have a spring, a spiral spring. A spiral spring. A spiral spring of natural length. Natural length. The natural length is given to be 30 centimeter, and the force constant of 20 Newton per meter is compressed to 20 centimeter. Calculate the energy stored in the spring. So we have the original length of the spiral spring. We're writing out our parameters. The original length is given to be 30. So let's say original length is 30 centimeter, and we are given the length after compression. That's the final length. The final length is 20 centimeter. So for us to get the extension of this, we are going to have E, which is extension, equals to 30 centimeter minus 20 centimeter. Extension will be 10 centimeter, which we need to express in meter. So that will be 10 divided by 100, which is 0.1 meter. 0.1 meter. And we are given the value of K, which is the force constant, to be 20 meter, 20 Newton per meter. K equals to 20 Newton per meter. and we are asked to find the energy stored in the spring. Energy stored, E equals to 1 over 2 ke squared. I've been given the value of K, and I've also derived the value of E by solving. So 1 over 2 times K, which is 20, times E, which is 0.01 all squared. That is 1 over 2. Okay, instead of 1 over 2, let's simplify that. We can say 2 will divide 2. 2 will divide 2, we have 1. And 20 divided by 2, we have 10. That is 10 multiplied by, this is 0.1, not 0.01, 0.1 square. So 10 multiplied by 0.1 square, 0.1 square, that will be 0.01. So multiplying this by 10, multiplying this by 10, we'll be having the answer for the energy stored to be 0.1 joule. The energy stored is 0.1 joule. The energy stored is 0.1 joule. So that is the response to the first evaluation question. The second question, we are going to solve it by ourselves and drop our response in the comment section on YouTube. So I'm going to give us the question, which we are going to do it by ourselves and drop our answer in the comment section on YouTube. So the question is as follows. The question is as follows. An elastic of force constant 200 Newton per meter is stretched through 0.8 meter within an elastic limit. Calculate the energy stored. So you are going to solve this question and drop your response in the comment section. Solve and drop your response in the comment section on our YouTube page, which is what A1 Tutor, on our YouTube page. So drop this on A1 Tutor YouTube page, A1 Tutor. So when you search for this, exactly under this particular video, it will be uploaded to the YouTube page. So exactly under this video, drop your answer in the comment section and tag it as question number 7. Thank you for your time today, and thank you for your attentiveness. Today we've been able to discuss work done in a spring or a string, and we're able to solve questions, able to solve 5 questions under that particular topic, which is work done in a string or a spring. And also we took one question as evaluation, and the second question, which is also an evaluation question, was given to us to solve and drop our response on the YouTube page of A1 Tutor. So we have concluded the topic elasticity. We had the part 1, the part 2, and today we had the part 3. So ensure that you do well to watch those videos, part 1, part 2, part 3 of elasticity, if you were not chance to follow the sequence. Okay, do well to watch it to have a detailed knowledge, and do well also to practice question using the A1 Tutor app. The CBT section, you have enough questions to practice there. Do well to practice the question using the CBT section of the app, and you get correction to anything you've done there. There are a lot of questions that have to do with this particular topic. By next class, we are going to take overrun solving question of part 1, part 2, part 3, basically using UTME question. We'll be solving UTME question, that is the JAMB questions that will cover the part 1 of elasticity, the part 2, and the part 3 of elasticity. Basically, JAMB question. Okay? Ensure you don't miss the next class, and tomorrow is another day. Make yourself available and be punctual. Tell a friend to tell a friend to tell another friend that A1 Tutor are offering free live classes, and their app are very helpful for preparation of exam and studies. Thank you and have a wonderful day.